now we want to talk about this thing called the common log and the natural log. Okay, so it turns out that you see, in your calculator, if you're going to find the number of buttons you have, you probably find one button that says log. Okay, now the log button in your calculator handles log base 10 only. Okay, why 10? Why 10 is such a special number? It's because our counting number system is base 10, right? You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, you repeat 11, 12, 13, 14. So it's what we call base 10. Okay, so if it's base 6, base 12 will be like our clock, right? So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then after that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a clock is what we call base 12. So our counting number system is base 10. Well, so naturally in the calculator they cannot have so many different base, otherwise every button one base, then you're gonna have a lot of buttons. So well, they just make it to base 10. Okay, so the button we have is for base 10, and that is why it's called a common log, because well, it's common enough. So it turns out that what we call log base 10 has a different type of a notation, right? It looks like this, LG. Okay, so in a lot of mathematicals, math textbooks, your worksheets, your homework, you see LG, you must know what it means. Okay, it means base 10, and that's it. Okay, now it also means that my calculator is now useful. I can actually use my calculator to calculate this log base 10 thing, right? In other words, I can now solve this. I can actually solve for x, right? Because all this while we talk about how log can be transformed into one form or another, and what it means, and how to get all the different special properties so called, but no practical use, right? So now with the calculator, I can actually solve for x. Okay, so let's think about this. How do I solve for x? Well, I need to make x the subject. Okay, and remember that one of the things that we learn is now that well, we are able to do this. Okay, what we call log both sides. So if I log both sides, they are still equal, right? So I log this is the equivalent of log that, right? Because they are equal at the first place. Okay, so I log both sides. And by the power law, right, we understand that log power something I can bring down the power. Okay, so then it becomes x log 10 equals to log 120. Okay, and of course, well, log base 10, this is 1. Okay, nothing special about it, it's just that so happen is 1. Okay, so 1, that means my x is actually log of 120. Okay, then go to your calculator, alright, press log 120, see what answer you get. Okay, it's usually a very long decimal number kind of idea. So with that will be the answer for x. Okay, alright, so then we want to talk about yet another button, which is next to your log button. You have this ln button. Well, that is what we call the natural log. Okay, by the way, it is called ln, which is actually spelled LN, not IN. Okay, so this is not in. All right, well, it looks like in. So the ln button, pronounced as ln, what we call for natural log, okay, is basically just yet another log is the same. Okay, except that well, it's base e. All right, so what is this base e? What's okay, well, 10 we understand, right? Counting numbers, base 10. But e, okay, well, it turns out that e is what we call an irrational number. Okay, now in our syllabus, we don't deal with a lot of irrational numbers. I mean, only we deal with pi since we were young, right? Pi is an irrational number. What is an irrational number, by the way? It's a number that can never be expressed as a fraction. Okay, so please don't tell me your pi is 22/7. Okay, it is not. Alright, so your pi is a number that has got decimal that's endless. Okay, there's no pattern, right? It just go on and on and on. That's why you can never express it as a fraction. So pi, well, e as well. Okay, so e is also another irrational numbers, and the rest of the irrational numbers comes in surds. Square root of any prime number is always irrational numbers. Yeah. Okay. So e is one of them. Okay. So if I don't remember wrongly, e is about 2.71 something. All right. So it is a constant for well, most of the time we deal with it when we talk about log. Okay. So it's called a natural log. Alright, so like pi, we deal with it when we talk about circles, right? Yep. So this one we deal with it when we talk about log. So natural log is what we call log base e. Okay, so e is just a constant. Think of it like a number. Don't be overly stressed over it. So if you look at this kind of equation whereby you have a e to the power of x kind of thing, right? And you want to solve for x. When you see e, obviously we will go and ln it rather than log it. Agree? Because if you ln, okay, what I mean is, if you ln it, ln both sides. Okay, take ln to both sides, right? This is actually, if you look at it in a different way, it is actually log base EE to the power x. Agree? Except nobody writes log base EE this way. People write ln. So, but you got to know this means this. Okay, and it's very, very useful because if I can bring down the power, I'm gonna have ln E equals to ln 10. Okay, so x ln E equals to ln 10. Ln E is 1. Okay, because it's log base EE. Is 1. It's just like the same idea here. LG10 is 1. Okay, you don't really see the base because you don't write the base anymore because it's a special notation for a special kind of log. Okay, so only these two are what we call special log, right? What we call common log and natural log. Okay, one is LG, the other one is ln. All right, so of course from here we can figure out the answer for x, which is x is equal to ln 10. Again, you go to a calculator. Okay, press ln 10 and see what you get for that. Alright, that should be the answer for x. Okay.